Good afternoon. This is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will discuss the component called as a ANOVA. ANOVA means analysis of variance. Okay. So, before I start with this concept of ANOVA, we will like to highlight what is the objective behind ANOVA. So, in the last class we have discussed the reliability of the models. In fact, ANOVA is one of the component under reliability of the bivariate econometric modeling. So, first of all, what is the objective behind this econometric modeling? When we will go for econometric modeling, the fundamental objective is to feed the data for a specific problems, and over the process we look for a structure in a data, that means a good fit. So, there is no hard and fast rules how to get the good fit or a good structure in the existing data setups. So, there are several procedures, there are several methods, there are several techniques. So, you have to apply to get a good fit. So, this is how you need lots of knowledge, lots of skill, then through which you have to design a models, or we have to find a structure, good structure in a existing data setup. There are, you can say, lots of permutation combination you have to apply to get the best fitted ones or best structure in the existing setup. So, one of such component we can say ANOVA, all right. So, there are the basic idea behind this good fit, or you can say good structure in the data set is you start with a specific problems by using any particular techniques or any methods, then there is a certain rules and regulations through which you can get a best fitted one. Okay. So, the basic foundation is you start with a specific problems. Okay. So, the moment you will get the estimated model, then your journey will start. So, now how to get all these details. So, now last class we have discussed the details about the estimation of econometric models and the reliability part of the econometric model. So, today we will start with this particular specific component ANOVA. So, this term ANOVA stands for analysis of variance. Okay. Analysis of variance. The term ANOVA stands for analysis of variance. It provides information about the levels of variability when a regression model and a basis for test the significance. So, you have to find out the reliability part of this particular model fit. So, the moment you have best fitted models, so we like to know how variability we can have in this existing setup. So, this is what we investigate through this component called as a ANOVA. ANOVA stands for analysis of variance. So, that means, so here this particular ANOVA with respect to bivariate econometric modeling. Okay. So, now we have discussed for bivariate econometric modeling. So, we must have two variables y and x, and through which we have fitted the model y hat equal to alpha hat plus beta hat x. Okay. So, in the last lectures we have discussed, last couple of lectures we have discussed several structures or several ideas behind the reliability of the estimated models. So, now means once you have the estimated model, your specific idea is to test whether these parameters are statistically significant, and in the same times the fitness of the model must be statistically significant. So, that means we must have two specific objective, the model significance with respect to parameters, and another is the overall fitness of the model with respect to R square. So, that means here we have two specific objective. You like to know alpha hat should be significant, whether it is significant or not, and beta hat should be significant or not, and second, to get the value of R square, which represents the degree of model fit. Okay. The degree of model fit means with respect to best one. Okay. And the whether this R square will be statistically significant. This is how we have to decide, and through which we have to prepare a structure, best structure within the existing setup. So, that means what we means what is our agenda. So, with the available information we have to fit a models, then we have to look for the best one. So, there are many ways we can fit the data with respect to existing problems. Even if there are two variables, say you can say stock price and you can say forex, foreign exchange. So, even if we will fitted the models whether stock price depends upon forex or forex depends upon stock price. So, still there are many ways you can start the modeling. Okay. So, there may be with respect to data transformation, with respect to means technique transformation, or with respect to assumption means relaxation. So many things are there, so that you will get a best fitted one. So, you go any process. So, idea must be to get the best structure within the existing setup, or to get the best one within the existing system. So, now so the first part is called as a reliability of the estimated parameters, and second part is the overall fitness of the model, model. So, this overall fitness of the model test is otherwise known as called as a ANOVA. Okay. So, what is this ANOVA structures? So, now once you have this estimated models, so the moment you have estimated models, so y hat equal to alpha hat plus beta hat x, then model information must have the structure we like to have is nothing but variance of alpha hat, then variance of beta hats. Okay. So, then standard error of alpha hat, then standard error of beta hat, and t of alpha hat and t of beta hats. Okay. And probability level of significance and probability level of significance. This is for beta. Okay. So, this particular setup is meant to know whether alpha hat is a significant one or beta hat is a significant one. So, within the existing information we like to know another component called as a R square and adjusted R square. Okay. R square represents the percentage of variation explained by the regression. That means, what is the influence of the independent variable to dependent variable in percentage term. So, that is how we calculate like the ratio between explained sum square by total sum squares. So, explained sum square will represent in terms of the influence of independent variable, and total sum square is nothing but the influence of dependent variable. So, we like to know the degree of influence through which through the independent variable to dependent variables. So, that is how we have represent the R square and adjusted R square. Adjusted R square is just to incorporate with R square and that to degrees of freedom. So, we will discuss detail what is the existing setup. So, what is all about this you can say ANOVA altogether. So, ANOVA specifically deals with the two things. Okay. So, let us start with this particular information tables. So, what we look for? So, we look for R square statistics and we look for F statistics. Okay. So, that means we like to know whether this overall fitness of the model is statistically significant. For this we need to have a prepare the ANOVA, that is an analysis of variance tables. Okay. So, what is this ANOVA analysis of variance tables? So, now we like to have sources of variations, okay. This is sources of variations, then sum squares, then mean sum squares, okay, then degrees of freedom, then F statistics and the probability level of significance. This is how you have to prepare the tables. Okay. So, the table information contains what is the sources of variations, sum squares, mean sum squares, degrees of freedom, and F statistics and probability level of significance. You see the idea behind this particular problem is, so when we look for econometric models, so we have two different structures. So, that means we have y equal to you can say a x component, that is data plus error component. Okay. This is what we will call it a error component. So, the existing setup is with respect to means what is the influence of x information on y, and what is not captured by x, that we will represent in terms of you can say error terms. So, we like to know what is the percentage impact on x variables, which is explained to us, and which is the not explained, that is called as unexplained, which is represented by error component. So, obviously, so there are two sum squares. Okay. So, first sum is with respect to explained sum squares, this is called as explained sum squares. Then there is a term called as a residual sum square, then there is a term called as a total sum square. Explained sum squares, so which is nothing but summation y head squares. So, this is summation e squares and this is summation y squares. Okay. So, now, so far as a means sum square is concerned, it is with respect to degrees of freedom. So, that means here y head square divided by you can say k minus 1. So, it is k divided by k minus 1. So, this is nothing but summation e square by n minus k, and this is nothing but summation y square by n minus 1. So, now the degrees of freedom accordingly, this is k minus 1, this is n minus k, and this is n minus 1. Okay, this is n minus 1. So, now we need to calculate f statistic with the help of above informations. So, now f statistic is nothing but the ratio between explained sum squares divided by residual sum square, provided it is the weightage factors of k minus 1 divided by r minus k, means it is n minus k. Okay. So, this should be followed by r square statistic, which is nothing but ESS by TSS. Okay, ESS by TSS. Let me exactly highlight what is this issue about these three. This three is nothing but like this. So, now our idea is here. Our idea is here summation y head squares. So, which is nothing but summation I equal to 1 to n. Okay. Now, y head minus y head bar whole squares. Okay. So, this is how summation y head square, because this is in small deviation format. Okay. So, now if we will simplify further, so this is nothing but summation I equal to 1 to n, then y head minus y bar whole square, because we know y head bar is equal to always y bar. So, this we have discussed long back. So, if we will simplify further, then this is nothing but summation alpha head minus plus beta head x minus y bar, you can say whole square I equal to 1 to n. Similarly, summation e square that is unexplained sum or residual sum is equal to summation you can say y head squares, summation y head squares, okay, summation y head square, summation e square equal to summation y square minus summation y head squares. Okay, summation y head square. So, this is the difference between these two. So, that means what we will how we will write it, means E is the deviation, E is nothing but y minus y head, because the overall structure is y equal to y head plus E. Okay. So, this is how error component is defined. So, that means it is nothing but y minus y head. So, obviously, when we will go for deviation, then it is nothing but y minus alpha head minus beta head x. Okay. So, to the power whole squares I equal to 1 to n. Okay. So, third component is summation y square, which is nothing but summation y minus y bar whole squares. So, I equal to 1 to n. This is how the entire structure of this particular analysis of variance. So, analysis of variance deals with the three specific components to check the reliability part of the model or to check the best fitted models. So, first component is explained sum squares, then second component is residual sum square, and third component is total sum square. So, we like to know what is the ratio between explained sum square to total sum squares, and we like to know what is the ratio between explained sum square by residual sum square. So, the ratio between explained sum by total sum square is represented by r square component, that is otherwise called as a coefficient of determinations. Okay. This is otherwise known as coefficient of determination. That means, we look for two things, first is r square, which is nothing but explained sum square by total sum squares, and this is nothing but what is ESS? ESS is nothing but summation y hat square divided by summation y square. If we will simplify, then the entire structure will be coming summation x y whole square by summation y square into summation x square. So, this is nothing but you can say this is nothing but you can say r squares, okay, correlation coefficient. Okay. So, then corresponding to r, we like to know whether this particular component is statistically significant. So, that is how we have to use f statistics. So, f statistic is nothing but the ratio between explained sum square by residual sum square. So, what we have to do? So, we will divide explained sum square by total sum squares, and we will divide residual sum square by total sum squares. Okay. Of course, there is a degrees of freedom here k minus 1s, and here degrees of freedom is n minus k. So, now what we will do here? So, this is one component provided there is a degree of freedom. So, k minus a, and this degrees of freedom is n minus k. Okay. So, k represents number of variables in the systems or number of parameters in the system, and represents total number of observations, it is total number of observations in the systems. So, now this ESS by TSS is nothing but r squares. Okay. So, it is nothing but r square by k minus 1. So, divided by RSS. RSS is nothing but TSS minus you can say ESS, okay, because TSS is equal to ESS plus RSS. Okay. So, obviously, RSS equal to TSS minus ESS divided by TSSS and whole divided by n minus k. Okay. So, this is nothing but r square upon k minus 1 divided by this particular term is equal to 1. Okay. So, this means 1 minus r squares, because this is one component and this is another component, this is r square and this is equal to 1. Okay. So, now this is 1 minus r squares. So, divided by n minus k. So, now this particular structure is called as a f calculated. Okay, f calculated. So, we like to go for you can say again f tabulated value with proper level of significance, means probability level of significance. Then like reliability of the parameters. So, we like to judge the overall fitness of the models. Okay. So, now I will take the similar problems, then I will highlight how we will go for this overall fitness test, whether this particular means model is good fitted or you can say best fitted. So, we have to start with this particular reliability of these estimated parameters, then you have to integrate with the analysis of variance, because most of the components we have to derive from this particular parameter value only. So, okay. So, what is the technical procedure of all these issues? So, now we have two variables. So, y variables and x variables. So, now over the time frame, the moment we will integrate y and x. So, we will get the estimated model y hat equal to alpha hat and beta hat x. So, then the moment you will get y hat equal to alpha hat plus beta hat x, then we can create another variable say y hat, which is means sorry, we will create another variable e, which is the difference between y minus y hat. So, that means here we start with y and x. So, we will get y hat, which is nothing but alpha hat plus beta hat x. Okay. So, then this is first variable, this is second variable, and we will get another variable y hat, and with the help of y and y hat we will get the error component e. So, altogether we start with the two variables, then ultimately we end with the four variables. So, y x, y hat and e. So, there are lots of games between y and x, then y hat, then again y hat e. So, we like to know how whatever variables you will use or how this way you will use, ultimately the objective or the agenda is to get the best fitted model. So, that means, so whatever structure you have created, so that structure should be best structure for you. So far as a data fitting is concerned. Okay. So, we have a problem actually. So, we have information, that is what we represent in the form of data. So, the data has to be properly applied to analyze that particular problem, and the way you will feed the data to analyze that problem. So, that fit must be best fit. So, that is how we are doing all these jobs. So, now, so we y x and you have got y hat and e, then ultimately, so we will take the similar problem here, the problem with respect to x and the problem with respect to y. So, in the last class we have discussed so far as the reliability of the parameters, that is alpha test and beta test. So, now we take these similar problems, then we will integrate this particular the significance of the parameters to significance of the overall fitness of the models. The reason is that if one is in favor of you and another is not in favor of you, then the model reliability is in the wrong shape. So, that is why the accuracy will be very high, model accuracy will be very high, or reliability is very high when all the parameters are statistically significant at the higher levels, and in the same times your overall fitness of the model also significant at the higher levels. If this is correct and this is not correct, or this is correct or this is not correct, then it will go against the model fit. So, that is why we have to redesign, restructure, reframe, so that the both the objectives can be go parallelly. So, that means your parameters should be statistically significant, and in the other side your overall fitness of the model should be statistically significant. So, now taking these particular problems, so here x contains 9 observations and y contain 9 observations. So, that means the first part of the modeling is sample observations are uniform and you can proceed, because with 2 variables and 9 samples it is possible to estimate. In fact, if the model information will be very high, then the model fitness will be also very high accordingly. Since it is in the class, so it is not possible to go with huge set of data, because the moment you will take huge set of data, then you need a statistical softwares. So, in the beginning we should not start with any statistical software. So, rather we start with a small problems. We like to know actually, or our objective is here to know what is the structure and how do we get this reliability, or how to test this reliability with respect to estimated parameters and with respect to the overall fitness of the model. So, that is why artificially we have created a small data set with respect to 2 variables, so that we can establish the concept very carefully. So, now the moment you have this much of information, then we have to proceed step by steps. So, what should be the first step and how do we go for our final objective? The final objective is to know the reliability means significance of the parameters, estimated parameters, that to alpha hat and beta hat, and second objective is the overall fitness of the models, that is the significance of R square. So, for that we have to integrate with the F statistics. So, now the step 1 process, is here. So, we like to know the descriptive statistics. So, as usual we have calculated already descriptive statistics for x variables and y variables. So, what is descriptive statistics? So, we are reporting a descriptive statistic is in fact it is a very complex and is a multivariate in nature, because descriptive statistics includes so many statistics like mean, median, mode, maximum, minimum, standard deviation, skewness, kurtosis, etc. So, in the meantime we need not require to represent all these details simultaneously, because when we will go for hardcore reliability part, then that times you need to have all such information. In the meantime we specifically highlight a few things, because these few things are very relevant so far as a reliability check is concerned. So, now first item we will consider is maximum, then second item is minimum, then mean, then standard deviations. Okay. So, now we like to know for x what is the maximum and for y what is the maximum. Similarly, for x what is the minimum and for y what is the minimum. So, now if we make here the standard procedure is without any calculation. So, just you arrange it ascending descending, very quickly you can guess it. Otherwise, you just give a command. So, automatically there is here mathematical properties and statistical properties through which you can get this statistics, the descriptive statistics, that is with respect to maximum and minimum. So, for this x, the maximum item is 81 and the for y the maximum item is 262. So, minimum item is for x is 32 and minimum item for y is 110. So, that means the for x the range is from 32 to 81 and for y the range is from 110 to 262. So, now you have x information and y information. We like to know how these informations are perfectly can be fitted. So, that is how our objective. So, now mean is here for x series it is 60.11, that is sum x by n, and here n represents total number of observation, that is equal to 9 here. So, this is mean for x and mean for y is nothing but 175.3. Okay. Corresponding mean we have a standard deviation here 16.53, then here standard deviation is 52.48. That means, for y series the standard deviation is 52.48 and for x series the standard deviation is 16.53. So, now with respect to all these information, you can take another two matrix, that is you can say covariance matrix and you can say correlation matrix. It can give you little bit indication whether there is any association between these two variables. So, far as a covariance matrix is concerned, it is nothing but sigma 1 1, sigma 1 2, sigma 2 1, sigma 2 2. Similarly, here R 1 1, R 1 2, R 2 1, R 2 2. So, this particular structure is nothing but this is with respect to you can say 1 stands for here x and 2 stands for here y. Okay. So, that means we can call it here instead of 1 1 we can call it sigma x x, okay. We can call it sigma x y, similarly sigma y x, then sigma y y. So, this is another way you can represent also. Similarly, this is r x y, this is this is r x x, this is r x y, this is r y x and this is r y y. So, this particular structure is very symmetric in nature, this is very symmetric in nature, and in this particular case it is always equal to 1.0, this is always equal to 1.0. So, we like to know what is the association between these two with respect to covariance, with respect to correlation. So, I am not calculating all these details because sigma x x is nothing but variance of x. So, which and if you will calculate if you will square root, then you will get the standard deviation. This is how it is directly derived. So, similarly, we will get the correlation coefficient. It is nothing but covariance of x y by variance sigma x and sigma y, standard deviation of x and standard deviation y. So, with this these are the basic information you need to incorporate before you go for the reliability test, because these are all essential elements through which we can observe this issue. Okay. So, this is the first step of this particular reliability check, or you can say analysis of variance. So, in the step 2, what you have to do, you report all these summary of this particular information. So, what is the summary of this particular information? So, the summary of information, because we have two variables. So, the summary of summation is summation x first, this is 541, then summary sum of y information is 1578. Okay. So, this is 1578 sum and this is sum x is 541. So, okay. So, now we like to know what is summation x square. Summation x square is equal to here 34705 and summation y square is here is equal to 298712. So, 298712. Similarly, and there is another component summation x y, which is nothing but 88291 and obviously n is equal to 9. So, this is first in the step 2, this is first step means first process. So, corresponding to step 2, okay, we can we will call it is step 2. Then in the step 3 we will transfer this into every small letter, that is in a deviation format. So, that this deviation format will help you to go for this analysis of variance, because if you will go with your original samples not in deviation, then it will take lots of time. If it is a classroom problems, so obviously you need to solve the problem quickly. So, as a result it is better, means the test can be in less time if we will move from this original sample to deviation format, because it will give you quick results. Okay. So, that is how we have to transfer this entire concept into deviation format. What is the deviation format? So, we like to know what is summation x square, we like to know what is summation y square, and we like to know summation x y. In fact, this summation x square derivation we have discussed in the last class, summation y square we have also discussed in the last class, and summation x y we also derived last class. So, directly we can specify here summation x square is nothing but summation x square minus n x bar square. So, if you will simplify, you will get 2186.09. Okay. So, that means summation x square is already here. So, you just calculate the x bar, then n into x bar square, if you will subtract from this summation x square, you will get summation small x square. Similarly, summation y square is equal to here 22046.52. Okay. So, similarly, summation x y equal to minus 6560.78. So, that means since covariance is coming negative, so obviously, so this particular item represent that. So, they are negatively related to each other. So, because variance is always positive for x and variance is also positive for y. So, the covariance can be positive, can be negative, and that will know the nature of the relationship. Since it is negative, so obviously the representation is that they are negatively related to each others. Okay. So, this is the step 3 process of this particular analysis. Okay. This is the step 3 process of this particular analysis. Now, what we will do? So, we like to know, or we like to go for this estimated parameters, because through the estimated parameters we will observe certain things, and that will be very helpful for this ANOVA analysis of variance. So, now what is this this we have to move to step 4. So, what is the step 4? The step 4 idea is here. So, the step 4 idea is here to discuss the reliability part of the models. Okay. So, what we have to do? So, the moment you will get all these information here. So, within the information we like to calculate first alpha head and beta heads. Okay. So, now step 4, you fit the model here, y head equal to alpha head plus beta head x. Okay. Alpha head equal to y bar minus beta head x bar, and beta head equal to summation x y by summation x squares. Okay. So, now we have already summation x y here. So, summation x y here. So, this summation x y we can put it here. So, this is nothing but minus 6560.78 divided by summation x square. Summation x square is here. So, 2186.09. Okay. So, now if we will simplify, then we will get beta head equal to simply beta head equal to minus 3.001. Okay. So, that we have also calculated today morning. So, now alpha head is equal to y bar minus beta head x bar. So, which is nothing but y bar. What is y bar here? So, y bar we have already calculated. So, that is what is y bar here? So, y bar is here 6.11 60.1 sorry 75.33 minus beta head is minus 3 into 001 into this x bar is here 60.11. So, this particular item it is 60.11. Okay. So, this is how the alpha head is derived. So, now with the help of alpha heads what will get it? So, if we simplify, then the alpha head component will be coming 355.72. So, this is alpha head value and this is beta head value. Okay. So, now the estimated model will be y head equal to 355.72 minus 3.001 x. Okay. So, this is alpha head and this is beta head. This is alpha head and this is beta heads. Okay. So, this is alpha head, this is alpha head and this is beta head. So, that means this particular item represents alpha head and this particular item represents beta head, and slope is coming negative. So, by default it is negatively related to each others. Okay. So, now after getting all these things, so next item is to check whether this particular parameter is statistically significant, means this particular value is significant and this particular variable significant, and for that you need to calculate the variance of alpha head and you need to calculate variance of beta head, and followed by standard error of alpha head, standard error of beta head, t of alpha head and t of beta head. The moment you will get t of alpha head and t of beta head, then you have to compare with the tabulated value, then you can get to know whether it is statistically significant, and if it is statistically significant at what level, that what we have already discussed in the last class. Just I am just integrating once again, so that the foundation, or you can say integration, can be perfectly okay. So, all right. So, now we have to move to step 5. We have to move to step 5. Step 5 idea is to check find out the variance of alpha head. Variance of alpha head is nothing but sigma square u summation x square divided by n summation x square. Okay. So, this is capital X, this is deviation x, okay, small x. All right. So, now variance of beta head equal to sigma square u by summation small x square. Okay. So, now we know summation x square, we know summation small x square, we know the value of n, but we have no idea about sigma square u. So, what is sigma square u? Sigma square equal to error variance, which is nothing but summation e square by n minus 2. This is nothing but n minus 2. Actually, it is n minus k, but since it is a bivariate model, so k represents 2. K represents number of variables in the system or number of parameters in this particular econometric system. So, since it is a bivariate setup, so k equals to 2. So, obviously, the error variance equal to summation e square by n minus 2. So, now what is summation e square? Now, for that, so summation e square equal to summation y square minus summation y head squares. Okay, summation y head square, summation y head square. So, which we have already derived how it is coming. So, what is our agenda here? So, we like to know first what is summation y square and what is summation y head square. So, by calculation we have summation y square is equal to 22046.52, which we have already calculated. Okay. Then summation y head square is nothing but beta head square summation x square. So, which is nothing but summation y head square is nothing but 19689.84. Okay. So, this is somewhat you can say summation x, this particular item is nothing but summation x y whole square by summation x square. So, we have already derived all these things. So, just we are reporting this value summation y square here, summation y head square here. So, we like to know what is summation e square. Okay. Summation e square is nothing but summation y square minus summation y head square. So, now if we subtract, then the final outcome will be 2356.68. Okay. So, this is summation e square, and that is how we have to integrate here in this particular structure, because we ultimately like to know what is the error variance. Okay. So, ultimately now what is error variance? So, error variance equal to sigma square u summation e square by n minus 2. So, summation e square is coming like this. So, this is nothing but 2356.68 divided by n minus 2. N minus 2 is nothing but 7, because n is 9 and k is obviously 2. So, n minus 2 represent 7. So, if we will simplify, then it will be coming 336.67. So, this is how it is the error variance. So, now with the help of error variance, you can able to get, or you can get, or you can able to get this alpha variance of alpha head and variance of beta head. So, now now what is the error variance of alpha head here? So, now variance of alpha head is equal to 336.37 sorry 336.67. So, this is what we have derived right now. So, that is summation e square sigma square summation e square by n minus 2 multiplied by summation x square by capital X square by n summation small x square. So, summation capital X square value is 34705 divided by 9 into 2186.09. Okay. So, if we will simplify this particular structure, ultimately you will get the item called the number called as a 593.86. So, this is variance of alpha head. Okay. So, similarly, we will get variance of beta head. So, variance of beta head is nothing but sigma square u by summation x square. So, this is nothing but summation e square is 336.67 divided by summation x square, which we have already derived 2186.09. So, this is nothing but 0.154. So, this is variance of beta head. So, but actually we need standard error of alpha head and you need standard error of beta head. So, what you have to do? We have to get standard error of we need to have standard error of alpha head and we need to have standard error of beta. Standard error of alpha head is nothing but variance of alpha head, okay, variance of alpha head and variance of beta heads. So, standard error of alpha head is variance of alpha head, which is nothing but coming 24.37. So, because that means this particular 5, this is nothing but 593.86 square root. Okay. So, this will be coming 24.37. So, standard error of beta head is equal to variance of beta head. So, 0.154 to the power 1 by 2. So, which is coming 0.392. Okay. So, now we have received variance of standard error of alpha head and standard error of beta head. So, now we have to go for hypothesis testing, because we like to know whether this particular item is statistically significant, and for that we need to set a hypothesis. Okay. So, what is this hypothesis? No, for you have to set hypothesis for alpha and we have to set the hypothesis for beta. Okay. So, that means we like to know whether statistical the alpha parameter, estimated alpha parameter is statistically significant or not, or beta parameter is statistically significant or not. So, that means the item will be significant if it has some value. So, obviously, we start with that this item has no value, then we reject this statement. So, because last class I have discussed. So, the moment you go for hypothesis testing, then you start with the integration of two hypotheses called as a null hypothesis and alternative hypothesis. Null hypothesis means the assumption you have to assume that the true statement is wrong. So, then you have to reject this wrong statement and we will be coming to the true fact. Okay. So, for that we have to assume that here for alpha head we have to assume hypothesis such that null hypothesis alpha head equal to 0 against alternative hypothesis alpha head not equal to 0, and similarly for beta head H 0 you have to assume that beta head equal to 0 and alternative hypothesis beta head not equal to 0. So, now the moment to test all these hypotheses, then we need to move to step step 8. Okay, no, sorry, step 6. Okay. So, we need to move to step 6. Okay. So, what is step 6? Since alpha head equal to 0, so obviously T of alpha head equal to alpha head by standard error of alpha head, okay, and T of beta which is nothing but how much here. So, now 355.72 divided by 24.37. So, this is what we call as a T of alpha head. So, T of alpha head we will get it 14.6. So, that means T of alpha head, this is equal to 14.6 and this is calculated T, this is calculated T statistic. Okay. Similarly, T of beta head is equal to beta head by standard error of beta head, So, which is nothing but minus 3.001 divided by 0.392, and if you will simplify you will get simply minus 7.65. Okay. So, now T of beta head is equal to minus 7.65. Okay. So, now you have to go for statistical test. Okay. So, for that you have to draw the normal distributions curve. Okay. So, now this is accepted regions and this is rejection regions, this is also rejection region, this is left-tailed test and this is right-tailed test, and this is together we call it two-tailed test. Okay. So, now let us assume that for a particular instance we actually this particular intervals. So, we will get through tabulated statistics. Okay. So, let us assume that at a particular level of sample size and particular degrees of freedom we let us assume that this del line you can say 2.12 and this side is minus 2.12. Okay. So, let us assume that the T of alpha hat the target line is 2.12 and this is minus 2.12. So, then we have to compare what is the our status of our T alpha hat and status of T beta hat. So, we like to know what is this, whether this particular item is significant and this particular item significant. This is our objective. So, now we have to place the tabulated statistics with respect to we have to place the calculated statistic with respect to tabulated statistics. Then we have to justify whether we have to conclude that or we have to justify that whether the null hypothesis is rejected or not. So, now what is the criteria here? So, we start with the T alpha hat. So, T alpha hat is 14.6. So, that means it is coming right tail. Okay. So, this is how it is called as a 0.0. This is origin. So, 2.12 means it is greater than to this interval. So, this 2.12 means, so 14.6 will be coming this side. Okay. This side will be coming 14.6, that means it is in a rejection side. So, that means once it is in a rejection side, so we are rejecting null hypothesis. So, that means our statement is that alpha hat not equal to 0. So, that means alpha is statistically significant. So, now if it is statistically significant, then we have to check it at what level it is statistically significant. Is it 1%, it is 5% or 10%, then you have to look into this items 2.12. So, this 2.12 is derived with respect to 1% level or 5% level or 10% level, then accordingly you have to give justification. Similarly, come to that means we are concluding that alpha hat is statistically significant, and of course, it will be highly significant, that means it is significant at 1% level, because 14.6 is absolutely very high. All right. So, now minus 7.65, minus 7.65 means this will coming this side. So, left side, that means minus 7.65 is coming this side. Okay. So, this is again rejected region. So, that means we like to we have to reject here the null hypothesis. The moment we reject the null hypothesis, then obviously we will conclude that this particular item cannot be 0, it will be statistically significant. Then again regarding probability level, we have to look what is the value at what level. So, accordingly we will conclude that this particular item is statistically significant for the time being. So, that means alpha parameters and beta parameters are statistically significant. Okay. So, now we have to look for this we have to look for its analysis of variance. So, now what we have to do? So, we have to go for analysis of variance. So, now the second part of the problem, since alpha parameter and beta parameters are statistically significant. So, now we have to integrate with the overall fitness of the model. So, overall fitness of the models looks for three items. So, summation y hat squares and summation y square and summation e square. So, what is summation y hat square? So, summation y hat square. So, let me highlight here what is summation y hat square. Yes, summation y hat square is here. Summation y hat square is equal to, this is 19689.84 and this is summation y square is equal to this is equal to 22046.52 and this summation e square is equal to 2356.68. Okay. So, now so that means I will write it again once again, let us better to very brief ANOVA. So, summation y hat square equal to 19689.84. Okay. So, then this is summation y square which is equal to 22046.52 and summation e square equal to this minus this, which is equal to 2356.68. Okay. So, this is how we have received these items. Okay. We have received these items. So, now we look for the ANOVA tables. So, what is this ANOVA table? So, we need explained sum squares. So, mean of explained sum square, then residual sum square, then total sum square. Okay. So, this is sum squares. Okay. Then mean sum squares. Okay. Mean sum squares. then mean sum square, then we have to obviously there will be degrees of freedom. So, explain sum square obviously explain sum square equal to summation y hat square, this is summation e square and this is summation y squares. Okay. Mean square is obviously it is nothing but, so that means y hat square is this much. So, 19689.84 divided by k minus 1, it is k minus 1. So, k minus 1 means 2 minus 1, it is 1. Okay. So, this much of value we have to calculate. Okay. So, then similarly summation e square is nothing but what is this summation e square, 2356.68 divided by residual sum square n minus k. N minus k means it is k equal to 2 here, n equal to 9. So, it will be 7. Okay. Summation e square. So, summation e square means this is 22046.52 divided by n minus 1. So, n minus 1 means it is 8. So, we have to find out its statistics. So, how much it will be coming. So, that means the picture will be like this. So, once again, so I will just highlighting the detail exactly item. So, this will be coming explain sum square. So, this will be coming 19722.04 and this will be coming residual sum square 330.565. Okay. So, now we know R square statistics. So, R square will be summation TSS. So, this TSS will be coming, how much TSS will be coming. So, this is a summation y square by n minus k. So, this will be exactly equal to equal to 22046.52 divided by 8. Okay. So, it will be coming 275, this is 2755.8. Okay. So, now your R square equal to ESS by TSS. Okay. So, if we will simplify this one, so this is ESS is 19722.04 divided by 2755.8. So, it will be coming what is R square value here. So, the R square value is here, this will be coming 0.895. So, this will be coming 895. Okay. So, now we have to calculate F statistics. F is the ratio between ESS by RSS followed by degrees of freedom k minus 1 and n minus k. Okay. So, this ESS is here 19722 and 0.04 and divided by degrees of freedom 1. So, corresponding by RSS is 330.565 divided by 7. Okay. So, that means we can directly just make the ratio between this and this, we will get this result. So, 19722.04 divided by 330.565. Okay. So, if we will simplify this one, then F will be give you 59.56. Okay, 59.56. So, now, so the moment you will get F, okay, so then you will again go for the statistical significance of this particular test. Okay. So, now we have to assume that this this particular item is equal to 0. So, again you have to fit the null hypothesis and you have to fit the alternative hypothesis. Then we have calculated statistics. So, that means F calculated is equal to 59.56. So, obviously, this is 0 labels 0.0. So, this side let us assume that the calculated value tabulated value is say 2.96 and this side minus 2.96. So, obviously, we have to check with respect to degrees of freedom and sample size, we have to get the tabulated picture of the left side and right side, then you can get to know where is the position. So, obviously, in fact, for F statistic it will obviously will be coming in the right side. There is no question of left tail test in this particular instance, because everything in square. So, it will be always in positive. So, that means this particular structure will be like this. So, we just like to know what is F calculated and what is F tabulated. Okay, F tabulated. So, now let us assume that if F tabulated is 2.96, obviously we will calculate with respect to degrees of freedom. So, since it is greater than two tabulated statistic, then we can conclude that it is statistically significant. We will calculate that it is statistically significant. So, that means in the in the case of f statistic, so the component will be always positive, and the positive value whatever you will get it, then you have to calculate the corresponding, you can say corresponding tabulated value, then you have to compare this calculated value to tabulated value. If it is greater than to that tabulated value, then you have to justify that it is statistically significant, and if it is statistically significant, then you have to look to what levels, is it 1%, is it 5%, is it 10%. Then accordingly we have to conclude that the model is the most reliable one, because our parameters are highly statistically significant, and also overall fitness of the model, which is represented by R square and is tested by f statistic, is also statistically highly significant. So, that means the model can be considered as the best model. So, that means our the data structure is the best fitted one. So, this is how we have to go for the analysis of variance, or the second part of the reliability. With this, we will conclude this particular component called as a reliability of the modeling with respect to estimated parameters and analysis of variance. Okay. That means overall fitness of the models. So, for this we have to conclude this session. Thank you very much. Have a nice day.